So in our first video, you guys saw kind of the setup and construction for confidence intervals in general, and then specifically if we're trying to estimate the confidence interval for population proportion based on one data set. The second video walked you step by step through a particular example. And this video, hopefully you guys tried the next two examples on your own and we're just checking your work here. So in your notes, we're on page 63 and 64. So on page 63, the first example, we're checking out the proportion of female computer science majors. That's our goal. So again, here our goal, construct a 90% confidence interval for the proportion of female computer science majors. All right, so whenever you hear that phrase, confidence interval, you should immediately think, all right, I need three specific things every single confidence interval. We need our point estimate, we need our margin of error, which has two parts, our multiplier and our standard error. Kind of get that in your head, same thing every time. Confidence interval, I need point estimate, multiplier, standard error. So we've worked through these steps here. First part, our point estimate. To estimate P, the proportion of everybody, use P hat, the proportion from the data, and they tell us that from our random sample of 30, 6 were female, so 6 out of 30, or 0.2, is our estimate based on the data. We need to assign with this a level of confidence and the variability we expect if we took a different sample of 30. So step 2, we've got our multiplier, which gives us our level of confidence. They tell us specifically in the problem that they're interested in 90% confidence. So when we do our calculation for multiplier, we want 90% in the middle, which leaves 10% left over, or 5% equally on either side. To find this lower z-score, I know the area to the left is 5%, so inverse norm of the area to the left. And that'll give me a negative number. We said in the last video, make sure your reported multiplier is always positive. So positive version of that is 1.645. So between plus or minus 1.645, we've got 90% of the area in the middle. And then our last piece is the standard error. So square root of p hat, 1 minus p hat over n. We expect p hat to vary by about 7% from sample to sample. Now we have all of our three major pieces here, point estimate, multiplier, standard error. All we need to do is start putting these together. So up here, our multiplier and standard error together give us that margin of error that we're going to add and subtract. So margin of error is multiplier times standard error. We found those two values previously, just multiply them to get our margin of error of about 12%. And last step, put it all together. What's our point estimate from the data? Here, one sample gave us 20% female CS majors. We're going to add and subtract that margin of error that gives us our level of confidence and takes into consideration that variability from sample to sample. So reminder, 0.2 minus the margin of error to get your smaller number first, and then 0.2 plus your margin of error to give the larger number second. And what good is a confidence interval if you can't explain what it means? So for your interpretation, remember we're looking for three things. First, state how confident you are. So we're 90% confident. If you want the more formal language, feel free to say something like this study is 90% confident. Second thing we're looking for is that you're saying what you're estimating. So here we're talking about proportions in this context, and it's the population proportion. So proportion of all, true proportion, you'll hear some people say that, population proportion, some indication that you're estimating a parameter for the whole population. Put that in context. We're talking about the proportion of female CS majors. And then last part, just give your estimate. What is that? What are we estimating that value to be between? So we're 90% confident that P is somewhere between 8-ish% and 32%. All right, second example is on page 64, and this one is based on a data set from 2011 by the CDC, in which 234,900 adults in the US were sampled. So that's our N, a really big sample size. And they found, based on that sample, that 20.6% met the physical activity guidelines for both aerobic and muscle strengthening activity. Our task here is to construct and interpret our 99% confidence interval for the proportion of all adults who meet those requirements. So again, I'm finding a 99% confidence interval for P based on this sample of 234,900 adults. Okay, so again, when you see confidence interval, think same three things: point estimate, multiplier, standard error. Okay, confidence intervals are very formulaic, step by step, same thing every time. Point estimate, multiplier, standard error. So for point estimate, we've got, we don't have to calculate anything here. P hat is 0.206. They tell us, based on that study, here's the P hat, or the proportion from the data. Done. Next part, multiplier, we want 99% confidence is what they're asking for in this problem. So for 99% confidence, we want 99 in the middle, or 0.99. So that leaves 1% left over. If you split that equally, we've got 0.5% on either side. So our multiplier is going to be the inverse norm. And if I want to find this version of it, the area to the left is 0.005. So 0.005. That'll give me the negative number. We said always report it as positive. Or if you want to go straight for the positive, the area below that would be 0.995. So you could do inverse norm of 0.995. Get the same place either way. Then our last important piece is our standard error. So square root of P hat, 1 minus P hat over our really big sample size. And we get this teeny tiny standard error. When you did this on your calculator, maybe you got some scientific notation. Totally fine. Make sure you write it down with the scientific notation. Don't drop that part. Hopefully you kind of thought about why the standard error is so small. It's related to something we said earlier, several videos back. N is in the denominator. When you divide by a bigger number, when you have a bigger sample, there's going to be less variability in your point estimate. So tiny variability because I have a really big sample size. Putting that together now in the next couple of steps, our margin of error was multiplier times standard error. Take the previous two steps to get our margin of error. And our confidence interval now, finally putting it all together, the point estimate based on one data set, we got 20.6% meet the guidelines, plus or minus our margin of error. Again, subtracting the margin of error first to get the lower end point, adding it to get the larger end point. And you know the routine by now. You have to be able to interpret this for it to be meaningful. Looking for those same three parts. Got to state how confident we are, 99% confident. State what you're talking about. This section is all about proportions. We're talking about population proportion. Don't say data or sample here. Give it a little context, a proportion of all that meet these physical activity guidelines, and then give your estimate between these two values. Notice that's a really narrow interval compared to our previous two examples. If you stop and think about it for a minute, it's really narrow because we're adding and subtracting this really tiny margin of error. And this margin of error was really tiny because I had a really tiny standard error. The standard error was really tiny because I had a really large sample size. All right, that wraps up kind of the examples for constructing a confidence interval. We have one more video in this section, and it's going to talk about some of the big ideas for confidence intervals, some of which we've alluded to here.